So finding the inverse of a function, we're given f of x is equal to square root of x plus 5. So same thing as before. First, what do I want to do here is f of x 1 to 1. And if I sketch the graph of this f of x, remember that this time the plus 5 is inside, so it's going to move it in the negative direction. But it's the same thing, you know, we end up with something like this. And is this a 1-to-1 function? All you have to do is, if I take a horizontal line, same thing, it's only going to intersect once throughout the graph, so I would conclude that f of x is one to one. All right, to find the inverse function, remember what I had just mentioned. Change it back to y equals to the square root of x plus 5, and then interchange the x and the y. So it's going to be x equals to y plus 5. How do I solve for y? How do I get rid of the square root? Yeah, so square both sides. That way these cancel out, so you're left with x squared is equal to y plus 5. And of course we want to isolate the y, so we got to get rid of this plus 5, so I'm going to do minus 5. So on this side I'll be left with y equals to x squared minus 5. And of course just rewriting it, symmetric property, y is equal to x squared minus 5. Don't forget, the last thing to do is to change back this y to the notation f inverse of x is equal to x squared minus 5. So this is my inverse function. Now the only thing from here is you want to make sure that you check it, because we're still not quite done. I would always, you know, go to your calculator and let's graph this. So let's clear this out. And while I'm graphing it, you graph it as well. Square root of, what was it, x minus 5? X plus 5. Here's the original one, and again it confirms that this is in fact a 1-to-1 function. But now let's graph what we got. According to our calculations, this is the inverse function. Is there symmetry here? What is happening here? Or what do I need to do to have symmetry? So here's my graph. Is part of it at least symmetrical? Which part? If I were to, let's say, take this portion away, is that going to be symmetrical? Yeah, so what values in the domain do I want? So I don't want these, the negative ones. Which ones do I want? Yeah, you want the positive ones, but how do I write that? But then I need to say, well, it's going to change my graph though. I want to restrict to only the positive x values, so I'm at 0 here, and I want to go off to infinity, so that's like saying x is greater than or equal to 0. So if I do this, and I exclude these right here, then this portion and this portion are going to be symmetrical. So that is why you always want to confirm that on your calculator. So when you go back to this, if you give me this as the answer, it's going to be incorrect. So you have to restrict the domain. So I'm not going to box this completely out anymore. It's still this, but I have to say such that x is greater than or equal to 0. So very important that if you give me that answer alone, it's going to be incorrect. You have to basically do this right here, so do not leave this out. Now I'm going to show you how to graph that so you can confirm that if I just graph for the x greater than or equal to 0, it will work. On your calculator, if you go back to the function, the inverse function, x squared minus 5, if you do control equals on your calculator, you have these less than, greater than, not equal to symbols, but you also have this vertical bar, stands for the such that. So you got to make sure that you put such that, and then x control equals is greater than or equal to 0. Now, the calculator will change that such that back to a comma, but it's not going to work if you put the comma. So you got to make sure that you put the such that. And now you can see that there is symmetry. If you graph that y equals to x line, if you fold along this, this y equals x line, you will have symmetry now. But that's why you have to put this or restrict the domain. X has to be greater than or equal to 0 for it to work.